Today, we're going to learn how the push method works in the priority queue. Hello, I'm James Helfrich. The priority queue implements push in a very particular way. It must maintain the heap constraint, which the topmost element is the highest value element in the collection. How does this work? We're going to take a look at that problem today. Adding an element to the priority queue is a two-step process. First, we add an element to the end of the heap, and then we call percolate down to make sure the new element put into the proper location. So let's take a look at this heap. Notice the topmost element is 92, which is the highest value element in the collection. It is greater than its two children, 89 and 67. We can take a look at this binary tree to assure ourselves that every element is greater than or equal to the two child nodes. Now, our push algorithm is going to start by pushing an element to the back of the heap. Now, obviously, 85 is not in its correct location. So we're going to have to figure out what the index is of our parent. And so our index of our parent is 6. So we're going to call percolate down on index 6. So percolate down will take a look at its value and the value of its two children, 38 and 85, and you'll realize that 85 is greater, so we'll swap those elements. Then we're going to call percolate down on its parent. So we'll take our index divided by 2, which would be 3, and now we're going to realize that 85 is greater than 67 or 61, so we're going to swap with it. And then we're going to call percolate down on its parent, which is 92. Now, since 92 is greater than 85, we're finished. And now our heap is in its proper location. Okay, let's take a look at another example here. I'm going to have a list of elements, which happen to be in heap order, and I'm going to add them into my priority queue using the iterator non-default constructor. And this will add everything into the priority queue. I'm also going to put the indexes in here just so we can keep them straight. Now, when I call push 99, it's first going to add to the end of the heap. And then I call percolate down on index 6. And notice that the 73 is not greater than 99, so we'll swap it. Then we'll call percolate down on 3. Notice how 89 is not less than 99, so we'll swap it. And then we'll call percolate down on index 1, which is 90. And once again, 99 is greater than 90. When finished, our heap will look like this. Okay, let's take that code, copy paste it into the debugger. Now I'm going to set the breakpoint just before I push 99. And when I take a look at the heap, we're going to notice that the values in the heap are the same as they were in the list beforehand, because I was very careful about the order I put them in. But now when I step over push 99, notice how 99 is at the top, and now slot number 2 is 90, and so on. Now, these values are in exactly the same order we did them when we did them by hand. Let's verify that's true. Remember, 99, 86, 90, 79. And now that was the same order we had before, 99, 86, 90, and 79. It looks like that our by hand version and the debugger were the same. You can learn more about the push method of the priority queue by reading the push section in the priority queue chapter of the C++ data structures textbook.